This video is on section 4.5. It's our second day or our second assignment on 4.5. It's assignment number 29. You're actually going to be given logarithmic equations and we're going to solve them. Now remember, in a logarithmic equation we have an expression such as log base b of x equals y. B is the base. It has to be positive and not 1. A logarithm is the exponent, so y is the exponent. X is the argument, and in any argument must be a positive. Now when you solve a logarithmic equation, we've got to remember those definitions. You're going to have two types of logarithmic equations. One is going to be when you have a logarithm on one side of the equation, such as this one, log base 3 of x equals 5. The other when you have logarithms on both sides. Now that's what you're going to have to be aware of, that we're going to look at two types of equations. Okay, first let's look at a log on one side. Number 1, log base 2 of x equals negative 3. Class, the first thing I'm going to tell you is my calculator's no good to me. That's log base 2. I can't solve that. I'm going to convert that to an exponential. Remember, start at the base, go under the equal, and back across. That's 2 to the negative 3 equals x. My math lab's going to want you to go farther. Remember, to get rid of a negative exponent, you pull into the denominator. So x is actually equal to 1/8. There's your answer. Now if you put 1/8 in place of this argument, it would be positive, so that's legal. You've got to check that. Let's look at number 2. Log x equals 1. I have a log on one side. I'm going to convert to an exponential. My understood base is 10. 10 to the first equals x, so x is 10. If I place this 10 here for the argument, it is positive. That's legal. Number 3, ln x equals 2. I have an understood e here. Let's convert. E squared equals x. That's all they want you to do. They don't want you to go to a calculator. That would be your answer. Number 4. Again, I'm going to go to exponential form. That'll be 2 to the third power equals x plus 4. So that's 8 equals x plus 4, or x equals 8 minus 4, which is 4. Now, if I put this 4 into this position, 4 plus 4 would be a positive number, so that would be a legitimate answer. Now, here's where we're going to change a little bit. In problem number 5, I still have a log just on one side of the equation, but you see two logs added. We've got to go back to a previous section and say that we associate addition with multiplication. We have to combine that down to one log. Now we're going to change this to exponential. That's an understood base 10. So 10 to the first equals x times x minus 9. Well, that's 10 equals x squared minus 9x. Let's move everything to one side since that's a quadratic. And I'm going to factor. That'll be x times x, 10 times 1 with a negative 10, positive 1. So x equals 10, x equals negative 1. Now think, if you put negative 1 here, your argument would be negative. You cannot use that. If you put 10 there, your argument is positive. If you put it here, 10 minus 9 is 1, that's positive. You've got to check these and be sure that you are using legitimate answers. I'm going to skip number 6 for just a moment. I'm going to move over to problem number 9 on the next page of your problems that you have. I have two logs equal a number, so I'm going to combine these into one. Now remember, with a subtraction, we combine using division, so this is log of x plus 3 over x equals 2. Now let's change to exponential form. We have an understood 10 here. That's going to be 10 squared equals x plus 3 over x. Now let's do one more step of simplification. 10 squared would be 100. Now when you have used subtraction, converted it to division, you're going to always get a proportion. And probably the easiest way to remember to solve this is to cross multiply. It really doesn't matter which direction, but let's multiply. 100 times x and then x plus 1 times 1. This is a linear equation, x plus 3 times 1. This is a linear equation, so I need to move all my x's over. 100 minus 1x would be 99x. I need to divide, that would be 3 over, let me get up where you can see this, 3 over 99, and that would reduce to 1 over 33. If I put this x in either of these places, my argument would be positive. Now you notice that we used addition as multiplication, subtraction as division. Now we need to go back now and look at one of your problems, such as number 6. Now what I want you to realize on number 6 is that I have logs on both sides. The first thing I have to do is to combine 2 logs down to 1. So this subtraction tells me to divide x plus 5 divided by x minus 3. Now when you get to a log on each side, you can simply drop the logs and you have x plus 5 over x minus 3 equals 2. Remember, that's a proportion. I'm going to write that as a fraction, and I'm going to cross multiply. X plus 5 times 1 equals 2x minus 6. Now at this point we have a linear equation. Let's get all of our variables on one side of the equation. So 2x minus x would be x, and move the 6 over, and we would get x equals 11. Now if you put an 11 here, 11 plus 5 would be positive. If you put 11 here, 11 minus 3 would be positive, so that answer is fine. I think I have time to work one more. I'd like to work number 7 because it is a natural log. And my point on this is, if the problem comes to you as an LN, you work it as an LN. If it comes as LOG, you work LOG. Alright, we have natural log, natural log, natural log. I need to combine the left side into 1. Subtraction would be division. Because I have natural log on both sides, I can ignore it. Now I need to write this as a proportion, and I'm going to cross multiply. 3x minus 12 equals x. So that's 3x minus x equals 12, or 2x equals 12, or x equals 6. If I put my 6 here, it's an argument, it's positive. If I put it here, 6 minus 4, my argument is positive. So that would be my answer. 2 ways to work logarithmic equations: when you have a log on one side and when you have a log on both sides.